Hello, welcome back. In this lecture, we're going to take a deeper look into the relationships between the net present value method and the internal rate of return method. And to do that, I'm going to introduce a new tool called the net present value profile. The NPV profile is basically a graph showing the net present value of a particular project at different discount rates. Now, when we evaluate a project, we have one single discount rate, and that we'll talk more about that in future chapters. But in the moment, just remember that the discount rate should be consistent with the risk of the project. However, the future is uncertain, and when the Federal Reserve, for example, changes the target interest rate, it may affect future interest rate. So it is often useful to look at potential interest discount rate that is relevant for a project. So a net present value profile is a graph that shows the net present value for a particular project at different discount rates. So first, let's take a look at how we will create the net present value profile. We're going to use the example that we have been using throughout this lecture, this class, and that is the project with the cash flows. Remember this project? Okay, so we're going to use this project in our example. The first step is we're going to enter all the cash flows into the cash flow register. So you can see I've entered all the cash flow into the calculator as we've done before. And what we're going to do is we can compute net present value, but we can compute that net present value not just at 12%, but at different discount rate. So we can start with 0%, for example, and then we'll compute, press compute, net present value. So that's the net present value of this project at a discount rate of 0% is $60,000. And we can also enter a discount rate of 5%, for example, and press compute again. And we find that the net present value for this project at a discount rate of 5% is $38,000. And we can continue to do that with different discount rate, for example, at 10%, and then compute net present value again. So the steps to compute the net present value profile is to compute the net present value for the project using different discount rates. As you probably noticed, that's a rather tedious process. And as we do more of this kind of what-if analysis or scenario analysis, Excel is a much more useful tool than the calculator. So I'm going to introduce that here on how to use Excel to compute the net present value for a project. So before we go ahead, I want to first explain how the NPV function is implemented in Excel. What you have to understand is that the net present value is a very general concept, but when the software engineer developed the tools in the financial calculator or the NPV function in Excel, they implemented the methodology slightly differently. The software engineer for Excel interpreted and implemented the NPV function, assuming that we are computing the present value of future cash flows. So when you use the NPV function in Excel, so here is the NPV function. The first argument is the discount rate, which is relatively straightforward. The second argument, notice in here it says value 1, value 2, value 3. These are the values of different sets of values starting in year 1. So we want to include only cash flow in year 1. And then we want to add back the cash flow in year 0. So notice that cash flow in year 0 is not computed inside the NPV function in Excel. So that's a major distinction between the Excel's NPV function and the financial calculator's NPV function. Now, once you've entered the formula in Excel, we can look at how we can copy this formula so we don't have to enter it every single time. And when we do that, we have to look at when we copy the formula. So for example, here, we want to compute net present value at different discount rate. So as we copy this formula down one row, we want to see which of the values we want to keep and which of the values we want to change. So the first argument, the discount rate, we do want that to change because we want to compute different NPV value at different discount rate. But the second argument, the cash flow, we don't want that to change because we are using the same set of cash flow to compute different net present values. So to do that, we have to make that cash flow absolute. And the same is true for year 0. So if we don't want the value to change from one calculation to the next, we want to make the cell address reference absolute. So if you have questions about this, I encourage you to review a little bit more about Excel. For a lot of you, you may use Excel on a daily basis, and this is something that is very intuitive for you. So once we have entered the formula for the first computation, we can copy it to the rest. And as you notice, we get the same answer as we did from the calculator, and this should be expected. So what we have seen here is that at a discount rate of 0, the net present value is $60,000. As the discount rate goes up, net present value goes down. Again, that's something that we expect to see. And so at a discount rate of 15%, net present value goes down to $3,000, and at a discount rate of 20%, net present value goes down to be a negative number. And when we plot these numbers on a graph, this is what we will see. So the discount rate at 0%, we have a net present value of $60,000. And as the discount rate increases, net present value decreases. At discount rate of 20%, we have a negative net present value. And notice that at the discount, and we can see where the internal rate of return is. So at the discount rate of around 16.13%, the net present value is exactly equal to 0. And that is the discount. Then we call that particular discount rate the internal rate of return. So when we said that the internal rate of return is defined as the discount rate that sets the net present value to 0, when you see the net present value profile, that becomes a lot more clear. So what we can use now then is a tool for us to diagnose whether or not the internal rate of return is a good method to analyze a project. If you have a project that has irregular cash flow, again, irregular cash flow is cash flow that changes its sign from positive to negative or negative to positive more than once, then you want to do the diagnosis. The way you do the diagnosis is you create the net present value profile for the project. And if you see that the net present value profile looks like this, you have multiple IRR because the internal rate of return is when the discount rate sets the net present value to 0. So for this particular project, it has 3 IRR, and therefore, you will conclude that the internal rate of return is not a good method to use to analyze this project. In the next video, we're going to talk about what do we do when we have projects that demonstrate multiple IRR and we need to make adjustments.